Hello, so today we are doing this problem called word break. So the problem says that we get a non-empty string in the dictionary word dict that contains a list of non-empty words, and we want to determine if S can be segmented into space-separated sequence of either one or more dictionary words. And so we have, for example, this string Leetcode, and then we have a dictionary that we get as input with it. So the dictionary here contains leet and code. And the question is, can we segment this string in a way that all the segments are in this dictionary? And so the same word in the dictionary may be used multiple times. So we can have like leet code, for example. And we might assume that the dictionary does not contain duplicate words. So we have unique words only in the dictionary. And so for this Leetcode, we can segment it into only words in the dictionary by segmenting it into leet and code. For this one, apple, pen, apple, we have the word dictionary is apple and pen. So we can segment it. So we return true because we can segment it into apple and then pen and then apple. So apple, pen, and apple, because apple and pen are in the dictionary. For cats and dogs, cats and dog, like this. So there is cats, dogs, sand, and cat. The problem is this and here. There is only one D, but in order to be, we have and we have dog, so we kind of need two Ds, but that's not here. So no matter where we segment, we will not be able to find the segmentation such that all the words are in the dictionary, so we return false. So that's pretty much it for the description of the problem. Now let's see how can we solve it. So this basically the problem says, can we segment it into Can the word be segmented into space-separated sequence? So the thing is, we have a string like this, and what we want is to be able to segment it into some portions here, and we have a word dictionary that such that all we want all segments to be in the dictionary. So the first thing we can think of, okay, let's just brute force and try to see if there is some, maybe, so we know that we need to find some segments. So we need like to say that, okay, this string here is in the word dictionary, let's say, and then ending at J here, this one is at this portion from I to J. Let's say, for example, we want to be able to find something like this, where we find that this here is in the dictionary, and then we advance like this and we find that this portion is in the dictionary, and then we advance like this and find this portion is in the dictionary. And so we want to do something like this. And so you can see here, because we are segmenting, a segment by definition is an interval from I to J, right? And so we want to find all those substrings that are in the dictionary, right? So that gives us kind of the idea of how can we have some sort of recursion, a brute force recursion for this, right? And so we can say, okay, let's just have some recursive function, let's say word break helper or something, and then we can just pass that gets to the two parameters that are important. And the goal here is that this should just return true. Returns true if the segment is in, if it can be segmented, with words in dictionary. So one way we can do this is by, okay, let's just start with 0, 0. Let's start with I and J both at 0, right? Like this. yeah, maybe let me just draw. Let's imagine this is the string. We don't care about what characters we have, just the string like this. And I think maybe XX is probably better. Yeah, I don't know. Let's just keep it like this. So let's say I and j's are at position 0. We start at position 0. What can we do from there? So if we start at position 0, well, we have only two options. Either the I to j is in the dictionary, which is just one character. If it is, then we say, okay, that's fine. Let's move I, right? Let's move both, right? So if si to j is in dictionary, that means we have two choices, right? We have two choices. We can either say, okay, let's try both choices actually. So either try the first choice by keeping I where it is and expanding, because maybe if we move I, we won't find a valid segmentation in the rest. But maybe if we did like just wait a little bit and advance j, maybe and considered this one and found that this one is in the dictionary and then moved I like this, maybe this is the valid segmentation, right? But this one wasn't a valid segmentation. So we have two choices we can make at each I and j position. Is if we found that this is in the dictionary, then we can either the two choices are either move I to the end of the segment that we just found, and move j to the next position after it, right? So basically that would mean, okay, okay, let's say we find that this segment here is in the dictionary. That the choice that I just described is, okay, let's move this one and to here, and let's move j to here, right? And check if this segment is well, we can move j here, but my segment here, in Python, if I do si and j would not be considered, right? And so just in order for j to be considered, like if both are at the same position, when I do this, I will get an empty string. And so just for the sake of Python indexing, I will need to move this to this position so that I can get only one character, right? And so I will move that and be able to check for this character and then for the other part of that segment. The other choice I can make is that, okay, I found that, let's say I found that this, I found that this here is a valid segment, right? Let's say I found that this here is a valid segment. And so I described already the first choice. The other choice is, let's just keep I where it is and let's expand and see if this one also is a valid segment, because as I said earlier, maybe this was a valid segment, but we can't find a valid segmentation for this. But for some reason, because of the words in the dictionary, this is a valid segment and this is a valid segment. And so that's another possibility. And so the other choice is move j to the next position. Which is j plus 1. So that's if it's in the dictionary. Now, if it's not in the dictionary, what choices do we have? So if it's not in the dictionary, so let's say j was here, and this portion here is not in the dictionary, well, I can't segment at this position, and so the only choice I have is expand j and try to see if this one is a valid segmentation, which means that if this portion here is in the dictionary, so that I can try the next. And so only one choice, right? At that point I have only one choice, which is move j to the next position, right? And so now that I have the choices that I need to do, I can just think about the base case. So my base case would be for s, if j is equal to the length of s, regardless of the position of I, that means I reach at the end. So I will be able to know if I have a segmentation or not, right? So when do I have a segmentation? If whatever the position of I is, if si to j is in the dictionary, that means I have a valid segmentation. Otherwise I don't, because I reached the end and I couldn't find the rest of the word in the dictionary, and so it's not valid, right? And so if j is equal to the length of s, I can just return whether this here is in the word dictionary, right? And you can notice here I'm comparing with length of s. Why is that? Because again, Python, if I do length of s here, I will be able to get the last character. But if I stop it at length s minus 1, then I would, with this, I would skip the last character. And so that's always something to be careful of. Now I said I will be starting with both at 0, 0, and then moving depending on which choices I have, which choices can I make. And so both will start out at 0. And so that means that my first call would be to return this word break helper starting at 0, 0 for both, right? And that's pretty much it for our recursion. We know at each step what choices we have. We know the base case, so we know how can we recurse in these two cases, and we know what should we call. And so that's pretty much means that we can write our recursion here. And so first the base case, which is this, and we said we need to return this, and the so here else return false, right? And we need to do this, the choices that we said here. And so the first one is if, just copying exactly what we said here. And so this, if this is in word dict, that means that I have two choices, right? And so when I have two choices, because I want to return true if it can be segmented, then whichever one gives me a valid segmentation, that's enough. So I can just use or here. And so the first choice would be, let me just first write them like this. So choice one would be, choice one would be to move I to the end of the segment that we just found. So that would mean to do, first we said that we are going to have a helper here that has I and j. So this is the definition of it. And so the first choice is calling this here with, as we said, moving I to the end that we just found, which is, the end is j. That's the end of the word that we just found. That's after it, because j is this one here, the last index is j minus 1. And so, and then moving, as we said, moving j to the next position, which is j plus 1. The second choice is move j to the next position but keep I where it is, right? And so this is the second choice. And so whichever choice gives us the valid gives us a segmentation that's enough for us, so we just return it, right? Now otherwise we have only one choice, which is move j to the next position, which is this here, right? And so we just return that. And as we said, we need the call to start out like this. That's pretty much it. So just to make this a little bit, we don't need these variables. I just wrote them for clarity. So let's just replace them to make this a little bit nicer. This is choice 2, and we can delete this. Right. Okay, so this seems good. It's always good just with other cases, but and edge cases. But I think this version is good, so I'll just submit. So you can see we have time limited exception, right? At this case here so you can see here the degenerate case, it's when it's duplicates and all the possible A's, all the possible prefixes are in the dictionary. So basically the reason for that is that this is terribly inefficient. It recomputes every state multiple times. And to show you that, let me just say print for I equal to I and j equal to j. So if I print this, Okay, so you can see here we called this case for I is equal to 0 and j equal to 0. Okay, this one is a little bit, there are not too many computations. Let's use one similar to the one that we just had time limited exception on. So let me just take a portion of it so you can see. Okay, let's not take all of them. So this would be the dictionary, and let's just take a portion of it so that we don't have too many. Yeah. Okay, so let's see here. Actually, let me just show you the string. That would be easier to see the duplication. So si to j, because if the string is the same and we can break it, we found that we can break it. Like if we find that we can break this one, and then next in the string we will find the same string, there is no reason to go ahead to recompute it. We can just use that, right? And so that's what I want to show here instead of the indexes, because the indexes may be different, but the string itself, if it can be segmented even in different indexes, then we don't need to recalculate that. We already know it can be segmented. Okay, so you can see here we call it multiple times for a, and that's not efficient, because once we know that a can be segmented because it's in the dictionary, there is no need to check again. So you can see the number of times we do it for a is really huge. And if we do for Leetcode, let's go back to our previous solution. So Leetcode is nice because there is not too many variations, because we just need to go once and then go twice. But you can see the idea that in the case where we had just repeated a characters, we recalculated the same state multiple times unnecessarily. And so the way to do that is, this is recursion, and so we can just apply memoization, and that would solve our problem. By the way, the complexity of this solution here, it's O of n to the power of n, which tells you it's really big, because every time we compute, and we do it for I and j move, I moves n times, j moves n times below that, and each of them does 2 calls, does actually 3 calls. So actually it's, 3 to the power of n. So each of them does 3 calls, and so you can see it's really big. The other, so I said that I'm going to do memoization, so I need a map to do that. So that would be something like this, and we need to just check if it's in the map. Don't bother recalculating it. And so I'm just going to store in the map a pair of I and j, the string itself actually. So I'm just going to store if si j in memo, then return memo of sij, and then store that. So that would mean this is equal to that, and this is equal to that, and then we can just return that at the end. Just standard. It's the same way you do it for any recursion that exists with the defined states. Okay, so let's run this. Okay, so you can see this now passes even the time limited exception, because we stored the state and we stored the result so that we don't need to recompute it again. So that was the first solution. The other way we can do this with this recursion, it's changing slightly the state. So it's still recursion, but it would be a slight variation. So let's see how we can do that one. It's just good to know and get used to different ways of doing things, I think. And so let's just say here our recursion is going to be a little bit different. And so what we are going to do is not pass I and j, just pass I, and that I would be just the start position of the string we are considering. And so if that start reaches the end, which is our base case, that means we are done, and so we can just return what is the state. So we can return if we can return true immediately because we are done, and we haven't an empty string is by definition is contained in the dictionary, and so we can just return true. Now otherwise we need, instead of going choice by choice, we are going to go through all the possible ends for this start, right? So we are going to go through all the possible end, so that would be a range. So an end can only start after the start, right? So that's just normal, and so it can only be start plus 1. And why is it start plus 1? Because we need to consider also the 1 characters. But remember, with Python, the last index, if we do sij or s start end, it's not going to end at that index, it's going to end at that one before that. And so to get the character at start index, we need to do start to start plus 1. And then we need to go to the length of, we need to go through the length of the string, right? So from the start, so if this is the start, say this is our start here, let's just call it s, and this is our end. Let's call it st. And so if, let's say, with our state, our start is here, and let's say our end is somewhere here, so we need to try all the possible ends, right? And so we try end here, see if that can be segmented. Otherwise we keep trying ends until we reach the end. And so to reach the end here, for that, it's length of s. And again, we do plus 1 because of the same story, because the last index of Python, it ends at the last index minus 1. And so we do that, and then we check if the string at start to end is in word dictionary. That means we find a partial segmentation, right? Then we need to just, so if we find that this is in the dictionary, let's say this portion here, we found that this portion is in the dictionary like this. So what do we need to do? If we found this in the dictionary, that means that we just need to check this portion, because we won't reach this here unless this was already in the dictionary. And now we just need to check if this portion is in the dictionary. What is that portion? And how do we check? We check using the same recursive call. And so by checking if this, and how can we determine this portion here? That's just the end plus 1, right? So that's just something that starts at the end, right? And since the end here, it ends at index minus 1, so the next one, so this is actually e minus 1, and so this is e, and so we can just start from end and see if this portion is can either is in the dictionary or itself can be segmented into portions that are in the dictionary. And so if that's the case, then that means the entire thing is can be segmented, because we already made sure, with the nature of recursion, we already made sure that this is in the dictionary. This can be segmented towards in the dictionary, and this can, and this can. And so if we have all of that, we can just return true. But if we can't, and so we found that either this part was not in the dictionary or this part can be segmented, then we need to just expand the end and try this portion again. If we can't again, we expand and try that portion. But if we can, then if this is in the dictionary, then let's try to segment this portion here. And if that's in the dictionary, great, we return true. Otherwise, advance E again, right? And so that's pretty straightforward. And so that would be done with this for loop. Now, if we went through the entire possible ends from that start and we couldn't find any segmentation, well, that's not possible. Then we can just return false to the caller, right? And then at the end, what should we have to start from 0, right? That's to be able to find if the entire string can be segmented, we have to start from 0, so we just return that. And so that's all we need to do. So you can see the difference with the previous solution, where we used the state of our recursion was two indices I and j, but here we are just using one state, which is the one variable for the state, which is the start position, and then we vary the ends until we are able to find the segmentation, right? The previous step we did it with 2 pointers, but here we do it with the state with 1 pointer, and then inside there we do a for loop. And so let's run this and see if it passes. Okay, so it passes that test case. Let's submit. We'll probably get time limited exception because of the same problem I mentioned for the previous recursive solution. And so we will do just the same thing, recursion with memoization, and to fix that. And so that would mean here we would check if start so since the state is just start, and so our memo in this case would be just with the start. So if start is in memo, then just return memo start. Otherwise, here we need to set the value, right? Memo of start, and then equal to true, and then we'll return that. Otherwise, here we'll set that to false and return that, and that's pretty much it. Okay, I have a problem with this one. So here I forgot to return this, yeah. Okay, so this solution passes again. Now, whenever we do recursion with memoization, we should always think about can we solve it with bottom-up DP. This is, in a way, is top-down dynamic programming. Some people call it just recursion with memoization, but also it's just top-down DP. And so how can we change that to solve it with bottom-up DP, which usually doesn't involve recursion and mostly involves just a for loop? So to do that, we need to think about things a little bit different. So we need to find our goal function, just a couple of things we need to find so that we can implement it easily. We need to find the state, we need to find the base case, and we need to find our recurrence relation. And sometimes we need to find also the order of iteration. And so sometimes it's just the normal order. And so the goal here is, can the string be segmented with only words in dictionary, right? And so you can see here with this can the string question, that directly tells us that our state should be a boolean, should return a boolean, so that we can, at the end, we can be able to compute this goal function. And so our state can be just can the sub, so let's call it dp of I. So set to true if we can segment the string ending at index I with only words in dict. So if we can find this state, basically, if we can find this, that means the goal function would be, well, just n-1, because that means that if it will be true if we can segment the string ending at n-1 with only words in the word dictionary, which is exactly what we are looking for. And so that's when the state is right, you can directly, or with just a small modification, find the goal function. Now, what is the base case? So for dp of 0, which is, can we segment, so else to false. So the question we need to answer for that is, can we segment the string ending at index 0 with only words in word dictionary? And so for Python, as I said earlier, because so can we segment the string? Let's call it instead s of I. So in Python, this here means that. So that means that we are looking for dp of n, because in order to get this string can be this string n here, this is the entire string. But if we do n-1, this is not the entire string, because this stops at n-2, which is not what we want. We want to stop at n-1, so we want this, right? And so for dp of I, we are going to consider if we can segment the string s I, which means in Python ending at i-1, right? This will make things easier for us. And so the string here is basically, can we segment zero with only words in word dict. And so basically one thing to think of is here is that let me just show you this quickly. So if I do s equal to this, what is s of 0? That's just the empty string, right? And so this is the empty string, and by default the empty string is in the word dictionary, and so that means that here it's true. Now what is our recurrence relation, right? So let's say we know dp of j. We know that, so if we know dp of j is true, which means we can segment I'm getting tired of writing this can segment string x, and so let's just write a property for that. So property p of I means we can segment s of I with only words in. So this is the property here. When I reference it, it means this. And so if we know dp of g is true, that means that the property p of g, which means we can segment s until j with all the words in word dictionary, is valid, is true, let's call it. And so let's do our iteration in a way that j is less than I, right? So basically what that means is that I'm going to say, let's take j here and look at these. If we know that that can be segmented, p of j is true here, then we can just look at the rest, right? And so if we have dp of g is true, then let me just delete this. Then what can that tell us about dp of I, right? That can tell us that if we can find that from j, which is j is before I, so j to I is in word dictionary, and since we know dp of j is true, that means that dp of I is true. This essentially means that if, let's say I is here, let's say I is here, right? And we know this is dp of g, right? This here is this portion here is dp of g. So this portion, dp of g, tells us whether this portion can be segmented into only words in word dict. So if we know this is true, and we know that this portion from j to I is in the word dictionary, that means that the entire thing can be segmented into, the entire thing has the property p of I, right? Because this can be segmented, this is in the word dictionary, so the entire thing can be segmented, right? With words in the word dictionary. And so we can just do this relation, this recurrence relation here. And so basically this equals true if this, otherwise it's false. And once we find that it's true, there is no need to continue the recurrent, to continue calculating, because we only need to be able to segment it once. And so we can just break out of the for loop at that point. So we have our recurrence relation pretty much. One thing we can do here to make things easier, so J is just the start of the string we are looking at, right? So J is just equivalent to start, and I is equivalent to end, because you can see here this is S start to end, and so I is equivalent to the end of the string we are looking at, right? Now what is the order of iteration we want to do? And so what we want, we know we want J to be less than I, and so we know that I needs to be the first for loop, and so we know that I needs to be the first part of the for loop here, and we know that J is just in the range of I, right, from just what we did here. And so since we already have the base case for 0, there is no need to check that, and so we can just check from 1 to the last character, which we said we want n to be valid there, and so we need to check until n plus 1 so that we can fill n. And then for J, it's going to be until I, and then we can just from there, so we know this order of our recursion, and then we can just here apply the recurrence. So we know the order of our iteration now. So now we are pretty much done. We can just apply this, and at the end we can just return this, what we said, which is dp of n. We can just return this dp of n. So now we have everything we need. We have the base case, the state, the goal function. We know what order of iteration we need to follow. We know what recurrence we need to do. So we can just implement this right away. So I'm just going to keep track of the length like this because I will use it a lot, and then I will need the dp array, so I will initialize it with false. And since I need it from 0 until the n index, I will do n plus 1 here. And then after that, we will need to do the base case, which is dp of 0 equals true. And after that, we can start our iteration like this and apply this here, apply the recurrence relation. So let's just put this above like this, and as we said, we can break out of the for loop because we only need one valid segmentation, right? And that's pretty much it, and we can return at the end, we can return dp of n. So you can see with that programming, once we find this with this analysis, the code is easy to write, and that's pretty much it. So let's run this. Okay, so that solution passes. And so what's the time complexity for this solution here? So so here we are doing one loop that is O of n, and then another loop that can go as much as O of n. It's often less, but the worst case it can go to n. So overall we have O of n squared here, right? In terms of space complexity, we have we are using one extra variable. That's one is constant, but we are using this table that is the length of n plus 1, and so the space there is just O of n, right? And that's pretty much it. So that's it for this solution. There is a way to make this slightly better by doing things a little bit differently. And so the way we can do that is instead of checking here so here I'm checking for J, but I know the dictionaries, and so I'm checking every substring, and that's really not necessary. I can just check reverse the check a little bit. And so instead of looking if the string is in the word dictionary and then doing this, I can just iterate through the word dictionary, the words in the word dictionary, and see if any of them is found with that has the end I. If it is, then I can just use that, right? And so the way we are going to do that is just change this portion a little bit. And so instead of going with I, we are going with words in the word dictionary. Before we were checking if it's in the word dictionary. Now instead of doing this, because we don't set to true if this is not true. And so let's just go through the words, because the number of words will probably be less than the number of substring that we need to go through. And so for that case, we need to, so if we need to check if this word ending at I is, if basically there is a word ending at I that is in the dictionary. And so to do that, first we need to find the start position. Let's call this end, that would be easier. And so what we are going to do here is we are going to say, okay, that would be end minus the length of the current word dictionary that we are looking at. We are looking if the current word dictionary is ending at end. And so basically what we are doing is we have, let's say, our end here, and we'll say we have a dictionary that has AB, CAB, and DA. So what we are looking at is if any of these words is one of these. Like, is this in the dictionary? Is this in the dictionary? Is this in the dictionary? So basically, and instead of checking with the string itself, we say, okay, AB, is AB this string? If yes, great, we found the segmentation. Otherwise, we check if CAB is if this word is equal to this word. If not, great, we move on. If it is, we found the segmentation. So that's the direction we are going here. And so once we check, if we check first, like let's say we have a word A, B, A, B, A, C. So you can see the length here is a lot more than this one. And so we would have a start index that is negative. And so that one is not valid. And so we need to check for that. So we need to check if start is bigger or equal to 0. And the other portion we need to check is if word is equal to the start and end. So basically so we go through AB, is this AB? So that's what we are doing here. And so the other thing, in order to set dp of E to true, that we need is we need this portion here, dp of G. And so what is G? That just start here. That's the equivalent of G. That's what we said here. And so we can say and dp of start is true. But just to preserve the same order that we did here, let's just put this instead here. And that's pretty much it. And so if we have all of these, that means dp of end, which is dp of G, we can set it to true, and we can do the same thing that we did here, break out of the while loop, of the for loop. And that's pretty much all we are changing. So we just changed the order of the checking. Before we were looping on J and checking with the word dictionary. Now we are looping on the word dictionary and checking if J is valid. Okay, let's submit this. And so you can see this passes, and this would be faster if the number of words in the dictionary is a lot less than the length of the string. Yeah, so that's it for this, I think. That's it for this solution for now. And thanks for watching. See you next time. Bye.